Okay, good morning. So we will continue the lesson on polynomials, and then I will also try to cover the new topic, algebraic identities. Okay, so I want to give you some examples so that you can refresh your memory and work on it, and then we will solve it together and go to the next topic, which is also, of course, not new. You have already studied that, so I just want to remind you and complete it. So let me write some examples here for you and ask you to do them, okay? Okay, so from now on I give you 20 minutes to think about them. Yes, some of them are very straightforward. I just want to talk about these last two. We had this in Math 2C. I just want to remind you. Okay, so please start thinking about them for 20 minutes and then we come back and try to solve them. And please make sure that you are doing them carefully because they are not hard. So one thing here in this problem, I am giving you a polynomial in two variables. I am asking about degree. You can talk about the degree of x, you can talk about the degree of y, but when I say degree, I mean the total degree. And if you remember, you have to find them individually and add them together. Yes? So if I ask you what is the degree of xy, x times y, with respect to x is 1, with respect to y is 1. But if I just ask you what is the degree of x times y, it's 1 plus 1, 2. Okay? Okay, so let us start doing these together and then try to check our answers using GeoGebra. So the first one, I don't know how many of you work this out. I think that is a simple problem. The only thing that you need to be careful is to be careful about your calculation, things like that. So usually, but of course the examples that I mentioned here are not of this type. For example, I have given you some expressions here and I ask you to simplify this expression. This expression on its own is already simplified. Be careful. When I finished writing, I was thinking that okay, might be I could give you some examples of this type as well. So I have asked you to put these expressions here and simplify. But sometimes this expression might be horrible itself. So I would say that in those examples, it is better to simplify this expression first and then plug these things into the simplified version of that expression, which of course in this case is irrelevant because this one is already in its simplified form. Yeah, so remember that one as well. Okay, so what do I need to do? What I have to do, I would write it, okay, a over 2 minus 3b. Of course, a over 2 means 1 over 2 times a minus 3 times b. Okay, what you need to do is patiently substitute these things. So a is 6a, so I open a pair of brackets, 6a minus 2b minus 4ab. And then I have minus 3 times b, but the capital B is expressed there is 1/3 of a minus 2/3 of b, and then minus 2/3 of ab. Yes, so first you substitute and then simplify. Simplification is easy here. What you need to do, you need to multiply the 1/2 in. 1/2 multiplied by 6 is 3a. 1/2 multiplied by 2, they are simplified to 1, but I have a negative sign, so it becomes minus b. And the same story here, so it becomes 2ab. This is very, very simple. And then you need to remember, you are multiplying minus 3 in, so it should be multiplied. So this negative sign is for all the terms, not just for the first one. So you take multiply minus 3. If you want, you can do it in 2 steps. Keep the negative sign, multiply 3 inside, and then remove this one. But it becomes tedious unnecessarily. Yes. So what I do, I just multiply minus 3 in, so it becomes minus a plus 2b and plus 2ab. Agree with me here? Yes or no? Okay, and then try to simplify. Can I simplify more? The answer is yes, because this one and that one are similar. This one and that one are similar, and these two are also similar. Okay, so 3a I have a, one of them is gone, so 2a is left, and then I have minus b here plus 2b there, so it becomes b, and then this minus 2ab totally cancels at 2ab, and that's the final answer. Yes, how many of you got this answer? Yeah, that's good. Good. So apparently we don't have any problems. So you have to, I told you that this is a little bit boring subject, but it is necessary. You have to improve your skills to be able to do this fast and precise. Okay, so now number 2. So this is simple, so let us not check this with GeoGebra. I will check the other ones with GeoGebra to learn how to do this, to remind you of doing that. Okay, the same problem here. Again, if this problem is given to me, before substituting these bigger expressions in, I would try to see if it is possible to simplify this expression on its own first, which is not possible. So if it is not possible, then I don't have any other choices. I have to substitute and then simplify. Okay? But remember, simplify first and then substitute is more efficient if possible. Okay, but here in this case, what I have a minus 2b minus 3c, and then what happens, a is just 5x to the power of 5 minus 1. Momentarily, let us keep the pair of brackets around it. And then I have minus 2 times that expression, minus 2 times b. b is given to be this expression. So this is 2x5 minus 3. And then I have what? I have minus 3 times c, and c is that expression. So this becomes minus 3 times x to the power of 5 over 3 minus 4. And then you have to expand and simplify as much as possible. I just removed the pair of brackets. There is nothing behind that. This becomes this. And then I multiply minus 2 in. So it becomes minus 4x to the 5. Remember, plus 6. And I multiply minus 3 in. Minus 3 that I multiply and cancel this 3. So minus 1 is left, so it's minus 1x5. And then plus 12. Yes? And then let us see. This one and that one are similar, but they are totally cancelled. Yes, I have 5x to the 5. 4 of them are gone. 1 is left. Another 1 is gone. Nothing is left. And then I have minus 1 plus 6, which is 5. Plus 12 is just number 17. So how many of you got this right? So good. Let us just look into this deeper. So it's very interesting. So it means that it really doesn't matter what value for x you are choosing. Whatever value for x you choose and calculate this combination, regardless of your choice of x, the answer is always 17. Okay? That's interesting to know. Okay, now we go and talk about the degree of the polynomials. So here, of course, I have only one single variable, so I can talk about the degree of that one single variable there. So this is the degree of p of x. So how should I find the degree of p of x? Do you remember the rules? So here I have a polynomial. This one on its own, the degree is the highest one, which is 4, but I'm going to raise it to power 3. And then this one on its own has degree 5. I'm raising it to power 5 and then multiply these polynomials together. and then I add x to the 10 to the end. Okay, so what happens here? So can you tell me, do you remember the rules? What is the degree of this one? And the answer is 4. But what is the degree of the total combination? Is 3 times. So it's better to write it like this. So it is 3 times 4. If you ask me what is this, I would say that the highest degree, do you remember, if I have a polynomial raised to a power, if I want to find the total degree, I have to find the total degree of this polynomial and multiply it by the power, which is in this case 3. So let me write it like this, 4 times 3. Of course it doesn't matter, but let us keep the order here. Okay, and then I go here, what is the degree of this polynomial? The highest value is 5, this is supposed to raise to power 5, so it becomes 5 times 5. If you say what is this, I would say this is the degree of this part. What is this? This is the degree of the first part. Okay, and then what should I do between these two? Do you remember? Yes? Add them, because now I am multiplying them, so I have to add them. Yes? And then of course, if you ask me what is this, this is the degree of that part, which is of course higher than the degree of this 10. Yes, what is the answer? 12, and this is 37. So this means that x to power 10 does not matter. Yes? Is that clear? But assume that this is x to power 40. So what should I do then? Up to here I get 37, but this is x to power 40, then it means that the degree is 40. Because I am looking for the highest power, highest exponent of x. Here it doesn't matter because I'm adding them. So the degree is actually correct. So this becomes 37. So that's the degree of this polynomial. Here I want to do the same, but when I ask you the degree, I mean the total degree. But we have to do them individually, okay? So if you ask me the degree of q of x and y, I can write with respect to x, I can answer the same question with respect to y, and then I can answer the total, the answer to the problem here. Respect to y, okay? Okay, so let us just do the same thing. If I ask you what is the total degree of this expression with respect to x, so it means that I am thinking y to be a constant number. But don't worry about that. So can you tell me, if I want to write it with respect to x, I will look at this polynomial. What is the degree of just single polynomial here with respect to x? What is that? What is the degree here?
3.
No, with respect to x. 2. So this becomes 2. And what is the degree of x here? 1. But it is raised to power 3. So it becomes 1 times 3. And then because this polynomial is being multiplied there, so what should I do? I should add them, but let me just write it a little bit smaller here. Okay, and then I have another term here. The degree of this polynomial with respect to x is 1. And then the degree of this polynomial with respect to x is 4. What should I do? Because I am multiplying them, I have to add them, yes? But then, what should I do? Do you remember at the end? So, there is no matter of cancellation. Do you think there is a danger of cancellation? No. So then in that case, it reaches to its maximum, yes? So what is the answer here? Is 3 plus 2, 5, and that's also 5. So the degree turns out to be 5, because the maximum between 5 and 5. Remember, this equality is not usually equality. What is the correct one? Less than or equal. The reason that sometimes it becomes less than, because sometimes we get unlucky and the highest term here and the highest term there turns out to be opposite to each other, they cancel out. But there is no matter of, there is no risk here of cancellation, yes, because the leading term, do you remember that is the terminology that I used? If I ask you what is the leading term here, the leading term here is x to the power of 2y3. The leading term there is x to the power of 3y to power 6. If you multiply them, it becomes x to the power of 5, y to the power of 9. This is the leading term of this part. And if I ask you what is the leading term there, this becomes x5, y to the power of 3. So there is no way that this can cancel that one out. So there is no way that I have this less than sign. It should be equality. Yes? Is that clear? Okay, anyway, but this is not finished. This is the degree with respect to x. But let me ask you, what is the degree with respect to y? Okay, can you answer me? The degree with respect to y here is how much? Is 3. The degree of y, the degree of this one with respect to y is 2 times 3. And then I have to add them to find the degree of the first part with respect to y. And the degree of the second part with respect to y is this one 1, this one 2. So this becomes 1 plus 2 because I'm multiplying them. Yes? And then again, there is no danger of simplification, canceling out, so I just take the maximum. So here is how much? Is 6 plus 9, and here is 3. So the maximum is 9. So if you ask me what is the degree with respect to x, the answer is 5. With respect to y, the answer is 9. But the total degree, or the degree, is what? Is what you got for x plus what you got for 9. Or what you got for... but this is not probably a good way to do that, or was it? Yes, it is clear, because you need to care about the leading term. And the leading term is this term. And that's 5 plus 9. So the answer is 14. But anyway, you don't need to be worried about this case, because the book is always talking about one variable case. Okay, but this is also, let us see, we can use GeoGebra to answer this out. So I open GeoGebra here. Is it yes. So I think there should be some instructions in GeoGebra. So you go to cast view here, and then what we do is we get rid of this graphic part. We don't need it, so I change the view. I take this out. Yes, that's good. Okay, now hopefully let me check. I just randomly write degree. Yes, there are some degrees instructions. Okay, good. So here you have some syntaxes. Degree of a given polynomial, or degree of a polynomial and a variable. So probably we can, for the first one, we really don't need to bother. We just type that one in. So I just write here, and then I type my polynomial in. So the polynomial is, let me just see, x to the power of 4, and then I go down minus 3x to the power of 2, and then I go plus 5x, and then I go minus x to the power of 3, and then we go out. Is that right? No, I have another power of 3 out there, and then immediately I have another. Please check my typing. X to the power of 2 plus x to the power of, oops, plus x to the power of 5, and then plus 7. And then I have another power. I don't know what happened. Why is that? Sometimes it is really boring. Okay, plus. And then what do I have? X to the power, no, 7. And then I go outside, e to the power of 5. And then we go plus x to the power of 10. X to the power of 10, yes? Am I doing everything right? So I don't know why this is not that visible. So x to the power of 4 minus 3x, so that's correct, yes? So let us check. So 37, what did we get? Yes, we also got 37. So that's also good instruction of GeoGebra, so you can use GeoGebra to find the degree of your polynomial. Let us also check the other one. So I again type degree. Yes, so this time I have more than one variable, so let us choose this one. Okay, so let me just type my variable, so my polynomial, x to the power of 2, y to the power of 3, and then I have minus x, and then after that I have x y to the power of 2, and then outside to the power of 3, and then I have plus xy, and then I have is that right? Okay, but I don't know, they don't talk about the total degree. We can also do that. Let us see. If I choose x, let us see how it goes. So the degree with respect to x is 4. So we made a mistake somewhere there. How is that possible? So might be there is a matter of simplification. We didn't see that. Yes, because I don't think do you see I have typed something wrong? X to the power of 2 y3 minus x xy squared to the power of 3 plus xy x to the power of 4 y squared plus 1. Apparently I haven't typed anything wrong, but the answer GeoGebra provides is 4. The answer I got was 5. Why is that? Let us check. So this is why it's always good to check your answers. Okay, so where do you think I have made a mistake? Yes, it is apparently 5. Yes, because I told you the leading term is x5. But what did I do wrong here?
Can you try expanding it in GeoGebra?
Yes, I will expand that, but with the whole point of this exercise is without expansion. Yes, because I was a little bit careless. Probably this one. No, it does not cancel that. So if you want the leading term, let us just think a little bit wisely. So if I want to find, so let me change the view of the camera. So let us see. Here, this is the leading term if x is involved. That's correct. But there's only one term. So if I raise it to power 3, it becomes that. And then if you multiply them, it becomes x. So there is a matter of cancellation somewhere that we didn't take care of, yes? Okay, so this is my leading term, which contains x to the 5. And then I also have leading term x to the 5.
I think GeoGebra did something because I don't.
But this is also very strange, yes, isn't it?
Even if there was something missed in the first one, the second one is definitely 5.
Yes, that's what I'm saying. So might be I have missed. So let me just go back there. It's very strange. So did I type something wrong here? X to the 2, y3 minus. Let me just expand that. That's a good idea. Let me see if I can cut this. Copy and pasting things in GeoGebra is a little bit weird. I don't know. Do you know how to do that more efficiently? Yes. Oh, it worked. All right. Control C. Okay, let me go here, and then I don't know why it is working like that, but I would use expand. Yes. Expand expression, and hopefully I can Control V here and then do that. Okay, so so I understand why. Probably GeoGebra, you need to put a product or something. That's very strange because after expansion, it's not simplifying that. How do you simplify using GeoGebra? Do you know? This is why I'm saying that it's better to know these things before going to national exam. Is there any simplify command? So let me write simplify. Yes. And then simplify function. Let me see. Control V. And then try to see how it works. It's acting weird. Yes. Yeah, I think that is something we need to know about GeoGebra. That is not something. So GeoGebra is taking it like that. So it is taking that. Okay, the answer is 4. Okay, because it is looking at the highest power. Or might be I have to put a dot between them. Yes. Yes. So let me put a dot everywhere. So here, but that is a little bit annoying. So where is dot? This is the product dot, and then I have also a product dot here. yes, and then I have a product here, another product there. Do you agree now? Let us see how it goes now. Now it is 5. So, but it was a little bit weird for me. So, no, but so we have to put that dot. So that is something, at least we didn't do something wrong on the board. But in multiplying, yes, Tim, do you want to say something? Yeah, probably we have to put that.
GeoGebra usually interprets two variables next to each other
as one single variable.
it does.
Yes, I think so. Apparently, in the at least in CAS view, this is how it is.
No, for algebra, it interpreted as a multiplication.
Yes, that was my intuition. But in expansion, you see, sometimes it is doing that, but sometimes no, it is not doing, because no, I don't know what is it doing. Okay. But at least we are on the safe side if we put the dot. Dot, I mean not this dot. I don't know if there is a difference. I'm just using multiplication symbol here, or you can put this asterisk or whatever. Okay, but anyway, we haven't done something wrong here. So that is what I'm saying. It's always good to work with GeoGebra, because this is what you are supposed to use in the national exam. And if that interpretation, you don't know the correct interpretation here, then you will rely on that, and then you get the answer 4, but the correct answer is 5. Okay, so be careful. What I'm saying, I'm also learning this. It's good to learn, because that's a free software application and we are always using it. Okay. So hopefully this will actually work. And then let me just do one more thing. Okay, now another copy paste. You see, this is the bad thing. Okay, now I can copy paste. Okay, when I right click, this highlight is completely gone. So I have to use Control C probably, and then I will come back here. I don't know why this is doing this to us. This is also, yeah, if you learned, please let me know. I go and change this one to Y this time. If I haven't done something wrong, what is the answer? It's 9. What I got is 9. So actually, so this is something we learned about GeoGebra. If you want to be on the safe side, put the product symbol there. Okay, another one. Let us talk about the other simplification. Okay, before going to that problem on the board. So how many of you got this answer? What is your answer about this problem? Yeah, just what is that say?
0.
Yeah, it is 0. Of course, I intentionally wrote this on the board because I want to tell you something else. Okay, let me first solve the problem as usual. Okay, as usual means that I want to expand that. Okay, so what we do, we just expand that. So the expression is equal to, I start multiplying that. So it becomes x times b minus x times c minus a times b plus a times c. And then I multiply the other one, x times c minus x times a minus b times c plus b times a. And then I multiply the last one finally. So it becomes, let me write two terms here, xa minus xb, and then I have minus CA plus CB. Agree? Yes? Okay, and then let us see. You have XP here, and you have another negative XP at the very end. They cancel out. And then you have minus XC, positive XC canceled out, minus AB, positive BA. They are the same thing, opposite. They are canceled. AC minus CA are also canceled. And then I have CB minus BC cancelled. And then finally this term and that term cancelled. Nothing is left, so the answer is 0. Yes? Okay. And by the way, when you are working on GeoGebra, you are like finding or discovering some new features which are interesting, or you understand what is the logic, please teach every one of us and share it with us, okay? So we can use that, because I just want you to have a software to be able to use it confidently on the exam. Okay, so here, my goal is to teach you a little bit different thing, a little bit deeper idea here. And that is a theorem in algebra called fundamental theorem of algebra. So if you have a polynomial, so this is called the fundamental theorem of algebra. If I have a polynomial px, and if the degree of this polynomial is say to be n, okay, greater than or equal to 1, of course, then it has been proven in higher level mathematics that the number of zeros of this polynomial is at most equal to n. Not exactly equal to n, but at most equal to n if you are working in the system of real numbers. So what do I mean? For example, if you have a first degree polynomial, 2x plus 3, p of x, you cannot have more than 1 0. Of course, you already know for a first degree polynomial, I have exactly 1 0. Yes? If you put this equal to 0, how many answers you get for x? Just exactly 1. But for example, for the case of quadratic equation, I cannot say that I have always 2 roots. No, because sometimes the discriminant becomes negative, I do not have any roots at all, or sometimes the discriminant becomes 0, I have exactly 1 root, and then if the discriminant is positive, I have 2 roots. But it is not possible to have more than 2 roots if the degree of your polynomial is 2. For the third degree, can you give me a third degree polynomial with exactly 1 root? The simplest possible case, probably. Yes? A third degree polynomial, so that when I equate it to 0, it gives exactly 1 answer.
X cubed.
X cubed equal to, yes, x cubed. X cubed is probably the simplest possible scenario, yes? Because if q of x is x to the power of 3, if I ask you to solve this equation, so you put x to the power of 3 equal to 0. If I ask you what is the degree of this equation, you say it is 3. But if I ask you how many answers you get just 1 answer, and that is what? 0. But when I want you to know, so let me just write the fundamental theorem of algebra. Okay, what is the content of this theorem? Let p of x be a polynomial of degree n greater than or equal to 1, then p of x has at most n distinct zeros, something like that. So if my polynomial is guaranteed to be degree 2, at most it can have 2 roots. If my polynomial, but it is not guaranteed that it has 2 roots. At most 2 roots. Okay, what this fundamental theorem of algebra has something to do with this example. Okay, this is what I want to tell you. Of course, I'm not saying that this is easier. It might need a little bit more work, but this is deeper. I want you to understand it from a deeper perspective. So, this polynomial is a polynomial of degree question mark with respect to x. what that is question mark. What's the question mark? So let me write P of x equals to x minus a times b minus c plus x minus b times c minus a plus x minus c a minus b. So that's a polynomial. The degree of this polynomial, by the way, when I say P of x, I am intentionally telling you that x is my concern. So when I say degree of P of x, don't ask with respect to which variable you are talking about. Of course, I'm talking about variable x because I have specified this here. So can you tell me what is the degree of P of x? 1. Why is that? Because what is the degree of x here? 0. X doesn't have here. But here is 1. 1 and 0. Multiplied, I add them, it becomes 1. The degree is 1, the degree is 1, the degree is 1, and there is no risk of simplification. Yes? If these numbers are, of course, different. Yes? Because this becomes bx, this becomes cx, and this becomes ax. If a plus b plus c is not 0, by the way, it is essential if I want to follow this. It shouldn't be 0. Because if this is 0, then the degree is not 1. Okay, so let us assume that a plus b plus c is not 0. Okay, so the degree is 1. But let me ask you to calculate this in your head. What is P of A? No, be careful. What is P of A? What does it mean? It means go to your P of x, replace x with A everywhere. If I replace x with a here, this totally vanishes. Yes? But if I replace x with a here, this one becomes a minus b. So let me write for you. A minus b, c minus a, plus a minus c, a minus b. Yes? Yes or no? So I just replace x with a. You might say why Babak is doing this. You have to be patient to see what is the connection between this way of writing and this deep fundamental theorem of algebra. So what is P of A? Can you tell me? These kinds of calculations I want you to be quick at. In a matter of seconds, you should say that this is 0. Why? Because A minus B is the same factor A minus B. A minus C is not here. It is C minus A, which differs by a minus sign. So this product is negative of this product. So they cancel out. Okay, is that clear? Now let me ask you another question. So can you tell me what is P of B if I calculate? Yes, let us do that. P of B, this becomes B minus A, this becomes B minus C. And when I put B here, this vanishes, and then there, plus B minus C, and then A minus B. What is the answer again in a matter of seconds? 0. Do you see that? B minus C is repeating itself here. Here we have B minus A, here I have A minus B. So they differ by a minus sign, the answer is 0. Okay? But look, what was the degree of the polynomial? 1. How many zeros you found so far? How many zeros you found so far? No, not so far.
So far 2.
2. One of them is A, one of them is B. It's violating the fundamental theorem of algebra unless the polynomial is of degree 0. So it should be 0 everywhere. Yes? Is that clear? So let me ask you this question. I have a polynomial P of x. I tell you that the degree of P of x is 2, but I simultaneously tell you that P of 2 is 0, P of 5 is 0, P of 7 is also 0. What is the conclusion you can get?
The degree of is 0.
No, I'm saying that the degree of polynomial is 2. So this fundamental theorem of algebra guarantees that you can have at most 2 zeros. But on the other hand, I am also giving you these 3 pieces of information that P of 2, P of 5, and P of 7 are all 0. So this means, yes, it's contradictory unless this polynomial is identically 0 itself for all values. So that's what I'm saying. Yes, you are right. It cannot be. That's the point. I mean that if you want to have, if you know on the one hand the degree of, because the degree of the polynomial is cannot be 2. Yes. Uh, so that's not a good way, by the way. But here it is clear that the degree is 1, or at most 1. Yes, because it happens that the degree vanishes. So what I'm saying is that if this, you see this polynomial, you see that this the polynomial is apparently of degree 1, but you see that you have 2 zeros. This cannot happen unless this polynomial is just identically 0, because if it's not identically 0, it means that you have a real first degree polynomial with more than 1 roots, which is contradictory. For example, let me just try to make the question a little bit different. So what do you think, based on the fundamental theorem of algebra, what do you think will be this one? If I write p of x, no, let me ask you to expand this. X squared minus a squared, b squared minus c squared, and then I have x squared minus b squared, c squared minus a squared, and then I have x squared minus c squared, and then I have a squared minus b squared. So if I ask you to expand this, of course, it is very simple. You expand that, you get the answer. But let us use the fundamental theorem of algebra again. So, what is the degree of this polynomial?
It's 2.
It's 2, yes? But if I ask you what is p of a, what is the answer?
0.
You see that this is 0. If I ask you what is p of b,
0.
0. If I ask you what is p of c,
0.
0. So this means that I have a degree 2 polynomial with more than 2 zeros. This cannot happen unless the polynomial is 0 itself. Yes? Is that clear? Yeah. So this is one way of using the fundamental theorem of algebra in a little bit deeper way to understand that. Okay, that is what I wanted to mention. So that's good to know about.
So you can know a polynomial is identically 0 if it has more than 1 0. Or more zeros than n.
More zeros than, yes. If a polynomial has more zeros than the apparent degree, then that polynomial should be identically 0. There is no other way, yes?
And exactly follow the logic we used. Like if so we're saying that for the degree of p of x to be equal to 1, we're saying that a, b, and c have to be distinct, or have.
Yes, I have to mention that in the problem.
And
In that way, I didn't need even to mention, because even if a, b, and c are not distinct, it still works. But if I want to work it here, it might be better that I can give number. So I mean, in that case, I have to be careful. I have to mention that a plus b plus c is not 0. I have to mention that all of them are distinct. And then I can use the fundamental theorem. So it means that in that way of solving, I really don't care about anything between c, a, b, and. But if you want to do something based on that, then you have to mention all the details. A plus b plus c is not 0. I should have mentioned that a and b and c are not equal. In this case, I should have mentioned that a squared plus b squared plus c squared is not 0. Okay, and then they are distinct. In that case, you can conclude. Yes. But that is, I just want you to find the connection, because you asked me, is there something? It just came to my mind. It's also, by the way, this is one part. I don't think they have mentioned the name, but this is one part of the lesson. So you need to know this fact. Okay? Okay, so let us go now to quickly calculate the other one. So at least one of them we can calculate. So here I have given you some polynomials a, b, and c, and we are supposed to simplify this and that. If you don't mind, let us just find the first one. Okay, so what's the answer? The first thing that I will do for the first one, I would write 2a minus a half b minus 2c. First of all, I try to open up these pair of brackets before substituting anything. So I will multiply this minus sign in, so it becomes 2a minus 1 half b plus 2c, because this minus sign goes here and there, and then I will try to put those expressions here. A is that expression, I put it here, so it becomes minus 2m, 2x minus 1, y, and then I have minus a half. Let us do this part in our head. There is a minus a half coming here, which will go and be multiplied here. So that factor of 4 will simplify that fraction for me, so it becomes minus 2y, and then I have 1 minus x m, and then finally I have 2 times c. So I will have 2 times c. Okay, so what I did in this case, first of all, before doing the substitution, I removed a pair of brackets to make it a little bit simpler, and then after that I change a, b, and c with those given expressions. And then I have to simplify that. Okay, and I think it's better to do it in our head, because minus 2m is supposed to be multiplied, and then later y is going to be multiplied again. But I can do it in my head in one go, yes? So what's the first term? Minus 2m and y are going to be multiplied here. So hopefully you agree it becomes minus 4mxy. Agree? So I'm just multiplying like that. And then the same thing here, plus 2my. And I do the same thing here, minus 2ym plus 2yxm. And then I have 2mx minus 1. And then do the simplification. So you immediately see that this one and that one are gone. What is left? Okay, I have 2mx. Let me write 2mx. It's alone. And then I have this one similar to this one, a factor of minus 4, a factor of positive 2, so it becomes a factor of negative 2. And then I have minus 1 at the end. Okay, how many of you got this right? Okay, fewer number. So I don't know. Is there something that you don't understand here so that I can explain? By the way, let us just do this with GeoGebra again to refresh our memory how we can do these things. So what we are supposed to do, we have to type that expression. So I have 2, let us see if it works like this. 2a minus, and then I have this 1 over 2, and then I go in front, I put capital B, and then what I do, I have minus 2c there. Let us see if it works in that way as well. Capital C, okay? And then what I want to do, I will go here and use this substitute. Yes, so instead of a, I have put that expression minus m pair of brackets. Oops, I think we have to put the dots here as well. Yes, what do you think? 2x minus 1. It's really annoying if that's the case. Y, and then, yes, let me just do that. Yeah, let me just do that, because it might happen. Okay, it might happen that I will have problems there. So here, what I do, I put this one as well. Yeah, it's very important to check later. For B, I have 4. I don't. Okay, let me just put the numbers also. 4 Y, and then a pair of brackets 1 minus X, and then you have again M. Yes. So I also need a star here. Probably I also need a star here. I don't know. Do you agree with me now? Okay, and what about C? C is m times x. M. So let me just put the star from the beginning. M times x, and then I have minus a half. Yes? Do you agree? Okay, so let us see how it goes. If I substitute, I will get that expression. And then I want to simplify. So if I want to simplify that, is this simplification, do you think? No. So I have to expand that. Yeah, expand. I don't know what this is doing. Yeah, we have to, this is important to think about this feature in GeoGebra and try to learn that properly. Because it is also involving the capitals, I don't understand why. Yes. Yeah, it is very good. Especially, I am very weak in copy and pasting things in GeoGebra. The features are not that standard. So if you find a way, please let me know. Okay, you can save my time as well. Anyway, I will not be able to finish the next problem. This is a review from Math 2C we had. I will come back to this in the beginning of the next lesson because that's important. I will solve these two problems for you, and then I will actually move to the next lesson, which is algebraic identities, and they are extremely important. Any questions? But try to think about that problem, these two problems yourself. And I would appreciate if you think about GeoGebra, solve this problem here using GeoGebra. I will also do another attempt myself, but please let me know if we can do it more efficiently. Any questions? Thank you very much.